Now in this problem video, we're going to determine how many copper atoms are in a copper penny with a mass of 3.10 grams. In this problem, we're going to assume something that isn't quite true. We're going to assume the penny is completely made out of copper, despite the fact that it actually has a zinc core. We're going to neglect that for today. Now, I've also provided Avogadro's number right here, 6.022 times 10 to the 23rd power. And we have the periodic table below. There's an important piece of information that you'll need to pull from that. Go ahead and pause your video, try this problem out, and then hit play to see how things go. Okay, so in order to start the problem, we need to finish finding all of our information. We're going to need the molar mass of copper, which is going to be 63.55 grams per mole. Remember that that's always going to be one of the possible units for our atomic masses. I'm going to go ahead and get rid of this periodic table to give us some room to work. Now, this will be a conversion factor. Grams per mole allows me to convert between grams and moles. Avogadro's number will act as a conversion factor that lets me get between number of moles, 1, and this number of objects within the mole. So my starting point is going to be 3.10 grams of copper. Again, we don't always have to write the chemical species, but it's a really good thing to get in the habit of doing right now, because eventually we'll be able to cross-cancel them in every problem. Right now, we can still work through it and can't cross-cancel it. You just don't have to. Still, I strongly urge you to start. Now, we're going to need to get from grams into moles, making this the next conversion factor I want to work with. Grams need to be cross-canceled, so they'll go in the bottom. 63.55 grams in 1 mole of copper, and then copper. Grams will cross-cancel, copper will cross-cancel. I'm currently in moles of copper. Next thing I need to do is get from moles into the final thing that it asked me, which was how many copper atoms. So I need to get rid of moles of copper, get to atoms of copper. And we can see here that when I cross-cancel my moles of copper, I'm now in atoms of copper, which is exactly what I was asked to find. So I can see that this will be the end of the problem. What I need to do now is put in my conversion factors. One large counting unit, 1 mole, equals a giant number of little things. Atoms are little things. So 6.022 times 10 to the 23rd power. So now we're ready to go ahead and grab our calculator in order to solve for this one. So we have 3.10 divided by 63.55. Now we'll do times 6.022 times 10 to the 23rd. I'm not going to put in the times 10 to the 23rd for the moment, because when I hit enter, it's just going to add it 23 places long. I'm just going to remember that I'm going to have to add 23 to the power. So 2.93756. 2.93756 times 10 to the 22. All that I've done here is I've just moved it over one place, because on the calculator it shows the decimal point. So when I slid the decimal place one time, it gave me this. Using a normal calculator that actually shows scientific notation, you probably were able to skip right past that issue entirely. But I'm missing some important information for any correct answer. I'm beating this to death and I know it, but that's a good thing. What other elements are required in a correct answer? Go ahead and pause the video and think about that for a moment if you need to. Okay, so I've got my correct value. Next thing I need to do is I need to have units on that. Got units. I want chemical species if I know it, and I certainly do in this case. But there's one thing I'm still missing, and that's significant figures. I had 3 sig figs there, 4 sig figs for my periodic table. This is infinite. Here I've got 4. I could go find more in a better conversion table, but we don't need to. That's also going to be infinite. So I've got 3 sig figs as my limiting factor. Right there is going to be my cutoff. So my final answer should be 2.9. Notice that this next number is higher than 5 and has digits after it anyway, so we round up. So 2.94 times 10 to the 22 atoms of copper. That would be my final answer. Correct sig figs, unit, chemical species, and value.